Okay, question 4.5. Using the US population dataset, estimate the US population in 1870 by using a linear trend line. Does the answer seem sensible? What assumptions did you make in your calculations? Would it be better to use what would be a better model to use to describe the population growth? Okay, right, let's go back to our spreadsheets and let me find that data set. Okay, so assumption here, let's assume, because we're talking about linear equations, that I can model the population growth of the US with a linear model. Okay, so let's plot a linear model, right? Let's do year versus number of people in millions. And I'm going to, again, do insert chart. There you go. Okay, so it looks linear actually, doesn't it? So I'm sure we can plot a really nice linear equation to that. So let's go to customize, series, and trend line, and then use equation, and there you go. You get an equation out of that. Now I'm asking what would be the population of America, or what was the population estimated in 1870? Okay. So I'm going to do 2.3. Move my mouse so you can see that. 2.3 times 1870 equals minus 4334. Okay, and I get a value of minus 33. Okay, which of course is nonsensical because you can't have a negative population. They were either there or they weren't. So the point I'm trying to make here is that a linear model is probably not appropriate to use in this case. Can you suggest an alternative one? Well, populations tend to increase in any other way other than linear, actually, in nature. We could try an exponential and see what happens. So let's try an exponential. And there you go. That's changed that to an exponential formula. We could also probably have used, let's have a look, a power law as well. Okay, they probably would have both given similar answers. So either one of those is probably going to give us a better estimate for the population in 1870. In fact, let's try that, right? So that's going to be 1.8 times 10 to the minus 62 times by 1870 to the power 19.4. Which actually estimates a value of 53 million. 54 rounding up, 53.6 million, which is a bit more sensible, right? It's not negative. I wonder what the exponential would have given us. Let's do that one. Let's compare that to 53. So it's 8.53 e to the minus 7. Times by e, exponential e, to the power 9.8, e to the minus 3, times 10 to the minus 3, I should say. And that gives me a value of, actually it's a very, very small value. Actually it's 0.86. You can't have 0.86 of a person. So I'd probably be more inclined to use the power law to estimate that. Obviously we don't, very, very difficult, and it's a bit foolhardy to really try and predict what the population of a country was 100 years ago from data we've only got for the last 25 years, right? But you can do it if you want and have a go at estimating. We don't know what happened in that time, those last 100 years. And of course, if you were to go and look at the graph and that data, I'm sure it would be a bit lumpy. It wouldn't be nice and linear like this one in the last 25 years. Okay.